Hello, I'm Martin Brook, and I'm here to talk about Duke University's Sony S Presence project. First, a little bit about Duke University. Duke University is a private institution founded in 1838. It's a relatively small institution with 6,000 undergraduate students and about 9,000 graduate students. It's a relatively expensive university to go to, but about 18 to 25% of the student, depending on the year, do have full tuition. It's ranked relatively high, about 20th in the world and about 10th in the United States. The admissions are rather selective. Apparently in 2020, they admitted 8%. I believe that number has gone down in recent years. So it's a very difficult university to get into. And the classes are relatively small. The student-to-teacher ratio is 6:1, and graduation rate is 90% across the campus. It's much higher in engineering. Speaking of engineering, here's some facts about Pratt School of Engineering at Duke. We'll talk about people. So there are 171 faculty, 124 of those are tenure track. We have faculty who are teaching, only faculty who do not have tenure. There are support staff, postdocs, PhD students, master's students. We have a relatively good-sized master's program and about as many graduate students as we have undergraduate students. The students by department, you can see my department, Electrical and Computer Engineering, is relatively large. BME, Biomedical Engineering, is the next largest department. Mechanical Engineering is next, and then Civil and Environmental. And this is a graduate program, a master's for management. Senior class, most of the students get jobs or go to graduate school. We'll see those numbers are slightly better for ECE. I think here's the ECE numbers. So you can see 94% of our students are accepted a position. Those that didn't go to graduate school. The graduates program has mostly been growing. There's a bit of a dip here in 2021 that was due to COVID and policies of the government in the United States at the time for foreign students. That's pretty much recovered, and we're back to large numbers of master students coming in. Research, Duke has had a growing research program. We're in the top maybe 15 research funding per faculty member universities. I think we have about $80 million of funding in 2021. I think that's up a little bit this year. We're funding from a variety of sources. Because of the biomedical engineering, a big chunk of it comes from National Institute of Health, then National Science Foundation and Department of Defense fund a lot of other programs. But we do have a significant non-governmental funding too. Pratt, as a contribution to the entire university's research budget, has been growing over the years, and I think it's gotten bigger than 34%. Most of this other percentage comes from the medical side. Duke has a large hospital. It's extremely well funded by National Institutes of Health. A lot of medical research. These are some of the grants, larger grants that Duke has had from NIH and NSF in recent years. 95 invention disclosures in this 2021, 39 patents, license agreements with industry, and a bunch of spin-off companies. We recently had a quantum computing company from ECE that got to ring the bell at the stock exchange when they went public. So a lot of research. Here's the website for Pratt. Now I'm going to go on to the topic of my talk, which is the X Prize Rainforest Competition. I'm co-leading an entry in the X Prize Rainforest Competition, and we're using the Sony presence as part of the technology involved in that competition. A little bit of background of that competition. This is the X Prize website. It's a $10 million competition. We were to get all the way through and win, I think we get about $4 million. There are prizes along the way. Next year we'll be competing in the semifinals, which we'd win $250,000 for if we won it. It's sponsored by the Alana Foundation, which is a woman who is a heir to a banking fortune in Brazil. They have come up with extensive rules and guidelines. There's the rules which came out in 2021. Basically, what it boils down to is they will give us a square kilometer of rainforest, and without people going inside the rainforest, we are to measure in 24 hours as much biodiversity as we can, and then we have 48 hours to process their measurements and produce insights into what happened. Currently, there are 36 competing teams, I believe, in 18 countries. A lot of them are actually corporately based, not universities, although there are quite a few universities. Here's our team, Blue Devil Rainforest Divers. So this is our site. We're currently busy filling out the semifinal submission form. We have to fill out a lot of documents. These things we didn't have to do. And this is what's in progress, is getting ready for the semifinals, which will be next summer. My co-lead is Stuart Pym, who's also a professor at Duke. He's a famous biodiversity expert in the Nicholas School of the Environment. And I wouldn't be competing without Stuart. He's great. Duke, the X Prize has a video that you can go and see about this competition. They talk about the rainforest competition and why they're doing it. And then we have made our own video where Stuart has been flying drones in rainforests for his nonprofit Saving Nature. This is a video he shot in Peru. We've also done an introductory to our team where we had some infrared video of lemurs and some video of us flying drones in the lemur center at Duke and Duke Forest, where we do a lot of our practicing. I spent a lot of time actually funded on a grant to decompose the Rainforest Challenge into individual pieces that could be manageable by students, mostly taking classes actually is how we do this. And they all revolve around flying drones into the understory and canopy of forests to measure things, collect stuff. These are all the things that we're doing for the competition. This yielded a whole lot of projects. Amongst them are camera traps and sound recorders, of which Sony has been one of the projects we've been looking at very hard to do that. We're actually going to test this technology this summer in La Selva Research Station. These are other places we could have gone. And our technology itself revolves around a number of things. One of them is this large drone, which is actually what I call our aircraft carrier drone. And here you'll see a video where a small drone lands on our large drone and then takes off. This is sort of in development, at least at this point. And there goes the little drone. The idea here is small drones, of which we'll talk about in a minute, are quite capable of flying into the forest, but to get a kilometer away, we need something to deliver them. And to save their battery, fly them out on this large mother drone and then deliver them into the forest. This is an earlier version of that drone. You can see it's quite big. It has gas-electric hybrid engines. We spent a lot of time designing it and optimizing its performance. This version of an earlier version flying in Duke Forest, where we do a lot of our practicing, one without the mounts for the small drones. And our goal is that thing will be disassembled, carried in 2 cases like this to the site to fly. Most of the little drones we use right now, we have about 17 of these that are operational at the moment, are Paradanafis. These are nice tiny drones, and the big thing about them is they can do this. They can look up. And it's not until this year that DJI, which is the main competitor for Parrot, has actually come out with a drone that can look up. If you want to get out of a forest, you want to fly down into a forest and get out, you need to be able to look up to see your way out of the forest. So that's a lot of why we use the Anafi. So here's me flying a drone when I first got one of these down into a forest behind my house to show that we can fly down in. And then once I got down in, I flew out. This is a student who had been flying a drone for about a week, flying the Anafi drone up out of a forest behind his house in Seattle during COVID. And he's actually going to go out through that clearing over here, fly his way up and out. And students have got quite good at this. We don't lose drones flying up in and out of forest because you can look around, see your way, and if we learn the right skills, and we can do this. Anafi family also concludes the thermal drone and the USA drone, which is a more advanced thermal camera. It's about a $7,000 drone used by military and utilities and police. We have 2 of these. We have 4 of the thermal drone, mostly due to cost, and 17 of the Anafi USA, and regular Anafis. The thermal drones are great in that they can do this. On the right, you can see us flying a drone up in the forest in the Lima Center. And on the left, you can see simultaneously shot infrared footage. And clearly there's something here. And if you look over here, you can see there's a lemur. So if we find animals in the forest, the infrared drones are good. We're not going to get that many animals. And the X Prize actually does count number of species. So this is like a secondary thing for us. But they also are very keen on insights. And I think insights have a lot to do with whether or not you find a cool animal. But you can also record the sound. So the way we are going to do sound and also camera traps, dropping off camera traps, we want to do that in the canopy. And here's our current version of a device for dropping something off in the canopy. So there we fly up and drop it off. And so that thing that's left swinging here has a device attached here and a magnet on top for recovery. We've actually modified this so where the magnet is now on the bottom, but this was an earlier version from a semester ago. Here you can see us flying up and recovering the device from the canopy with the magnet hanging below the drone. We now have a way of doing this above the drone so it doesn't interfere with the drone flight. So we drop off devices on branches with sound recorders. We also attach insect collection devices to the drones to fly out and collect insects for DNA barcode analysis. This is an older version. We have a better one that's more like a net. And then there's the question of how do we fly in forests? Well, you might think about what people do with racing drones, which is this, just fly straight into the forest and go fast through it. We don't want to do that. That's way too dangerous. We want to be very careful. And so we typically use these big holes that exist in the forest. This is someone flying up over the Amazon forest with a drone. You can see there are big holes way down in here. And we want to fly down into those sites. And we want to fly very carefully. We also fly along paths. These are students flying along a path in the Lima Center, very carefully, flying slowly. Turns out this is a good way to catch animals unawares. When you fly down above them, they get scared. But when you come in along a path, they think you're just another critter in the forest. So we do a lot of flying along paths to take photos of plants and animals. Parrot has an SDK, which is very useful. We can build applications. And so we built an application and we're building a whole multi-terminal, multi-display system. This is showing us it being done in a garage, GPS denied environment, where we can look up and then use commands to fly the drone up and then change commands. So we have this fancy SDK. This prevents the pilot from accidentally flying backwards, which is a very bad thing to do in a forest. And so we ultimately hope to have this kind of SDK coupled to a database of 3D flight information. And we're very close on that right now, actually, but it's not quite there. Once we collect this data, we use crowdsourced apps like BirdNet, where you upload the sound of a bird and then a community, an AI recognize the device. So the AIs typically characterize it and get it down to very close to what it is, and then community experts finalize that identification. There's another one called eBird. There's another one called Merlin, which is great for identifying sound. And then for images, we use iNaturalist. And we previously did an event in Duke Forest last summer where we identified 300 species with 23 people doing observations, and 207 people came in and helped us identify the species. So it's great when you can get this community support to help. This iNaturalist event currently has like 100 million images and millions of people who participate in it, and we'll definitely be using that to identify species. The other thing we're doing is creating 3D maps. This is some early work Parrot did with mapping an individual tree. We have done work with mapping forests. This is work where I have a small farm, and we did some mapping of forests at the small farm. And just to prove it's my farm, there we are mapping the house at the farm. And you can see where the drone's been flying. And these 3D models, this is a 3D model it creates, we're putting into a big GIS type database, and we hope to have geolocated all the species that we identify, coupled to the data we use to identify them. One of the things the XPRIZE wants us to is to have a traceable data provenance for everything we identify. So if you say that there's like a bird here in this tree, you need to be able to show, well, we did that by taking this photo or recording the sound of a drone that flew here, and here's the data samples we took. We collaborate with clubs at Duke. One of the main clubs we collaborate with is the AMA Club, which is a group that does drone flying. I'm the advisor of this club. They made a nice video of what they do, which is mostly fly drones and fly around, do crazy stuff. They build drones. This is where we get our big drone skills, is from this group, and flying little drones. So that's the AMA Club. We also, the AMA Club has this field that they can fly in, and there's also some forests around here that they're allowed to fly in. We also work with a group called Duke Conservation Tech, and they run they ran this meeting, ideation meeting, where they actually invited the XPRIZE people to it, which is great publicity for Duke. So they're more on the thinking about how you work and solve problems in the rainforest, more on the community side. We've also done things with Duke projects like Bass Connections. So my funding, this summer, we're going to Costa Rica. In fact, I'm leaving in a few days, and we'll probably present to the Sony meeting from Costa Rica. Funding for that came, part of it, from the Bass Connections, which is a Duke effort. So that's kind of it. And now I'd like to switch over to Achilles, who's going to give a presentation from the student standpoint. Thank you very much.